Hello everyone. This is our week 10 lecture, and today's lecture covers the topic of component design, or making our own families. So in class we've made one or two families. Maybe we did, I think we did a column family and we did a detail component family last week. So we've done a few creating a couple of families, but we've really made really simple families that are not parametric. They just kind of were the shape that we made them. So there's definitely, as you've seen, for example, this door, right? If I select a door, it can come in, a really narrow door, or it can come in the wide door that I was using. So making these parametric families is what we want to cover this week, is how do we go beyond what is pre-made, right? So there's only so many things that I can find when I go to insert and load family, and whether I'm looking on the internet, searching seek, loading what's already on my computer, there's only so many things and only so many conditions. There's going to be some components that you need at some point that you don't have, and you are going to want to make those things. So let's talk a little bit about kind of that process and going beyond that pre-made thing on what we need to think about or what we need to do to kind of accomplish those kind of goals. So we can make static things, and those are really, usually fairly simplistic families to make. So if the thing that you're making really only comes in one size, you don't need to worry about variability. But if the thing you're making, like this desk, comes in a 60 by 30 desk and a 60 by 30 student, I'm not sure what the difference is there, but it also comes in a 72 by 36. Same with a door, same with the windows. So if you have any kind of variability in your family, you need to think about how that's going to be accounted for, or what you're going to do to make that happen. So the thing is that it starts to become a challenge, because when you start to think about the variability of something, you have to make conscious decisions about how variable you want it. So, for example, I could have something that's called a door, and it could be, something as small as a mouse door, or like a gigantic airplane hangar door. Do I want to make, or a door that has, that's solid, but sometimes it has a window, and sometimes it's full glass, and sometimes it's a double door, and sometimes it's hinged to both directions. So I can make all of those variations. I could have a door that is that variable. I could make one super door, if you will, right? So I could make one super door, or I could have a single flush door, and then, a door that's very similar, but a little bit different, is say like a vision light door. So in this case, I might go and find a door. So I'll find the door that I want, and I'll use not the single. I need to find a single door in here. Single glass door. This family or this door is essentially the same. It even looks, even if I go and place it, right? Even if I put that door in here, it even looks almost exactly the same. If I zoom in a bit, you'll see they do have a slightly different appearance, but for the most part they're the same thing. There's no reason why I couldn't have made this and this be the same thing and just be a different type, right? So I could have had this, and in my pull down, instead of the different sizes, I could have listed, the sizes and that it was glass or whatever. So you have to think about how variable you want your thing to be, or how variable you want your family to be made, because the more complex it gets, the harder it is to author, but it's also harder for the user to understand. But if it's too simplistic and you only offer it in one size or whatever, then it becomes difficult to change anything in your model. So you have to kind of find the sweet spot of where that is. And it all depends on, how you work, or how your office works, and kind of the usage, that how you're putting together your BIM models will help you decide that. So early on, you may not necessarily know, but it's something that you gain a feel for over time. Right? So once you've decided how variable this thing is going to be, inevitably, one of the things that you want to do for sure is you always want to pre-design something. So you always want to, before you start modeling, the first step that you should try to take, or that you should take, is writing down exactly what you want to change So, I'm going to change the height and the width of the door, or I'm going to change the height and the width and make it so I can change the frame as well, the size of the frame, or the material of the frame, or the style of the frame. So write down kind of a recipe of everything that you're going to want to do, and make a list of all these kind of parameters or all these variables that you're going to need, and not only kind of what the variable conditions are that you need, is you need to make sure you understand kind of the stuff that isn't going to change. So in some cases, a tabletop is always going to be 2 inches thick because it's always made out of the same material, so it never changes the size. So you need to know the variable conditions as well as the invariable conditions, the things that are static. Or you may also need to consider things like intrinsic properties versus contextual properties, or extrinsic. Is that the word? Is that a word? I don't know. So for example, in a window, right? So internally, the window has, if I edit the type, internally, the geometry of the window is, 4 by 3, but it also has a default sill height, which is related to the external situation that you have. So you need to think about external relationships as well as internal relationships when you're making the family, because there are ways to connect these things to kind of the outside world as well. So that's another thing that you want to consider when you're making your list of parameters that you're going to use to control things and model variability, but also things that have relationships outside of your project. I've already kind of talked about the complexity of the thing, that you need to really consider that, and whether also, I guess, within the complexity is also, is this family that you're modeling very specific, or is it going to be widely applicable? So again, like the super family versus a really specific family. All right. As long as we're looking at parameters, so here, there are all kinds of different parameters that we can use. So in this case, we have some parameters that are, they have to receive some type of length included in them, or these parameters are material parameters, or we have other parameters that are maybe this has text and number values in it, or perhaps some of these only have number values, or in this case, here's a URL value. So here I can put in www.cnn.com or whatever. So now that link can be opened. But if I put in something other than a URL, it wouldn't work. So let me edit. Actually, let me cancel on this. Let me edit this window just so we can see when I'm talking about kinds of parameters that we have. So when we make components, we use this family editor, right? And we have ways of viewing these kind of complexities and variabilities. So let me look at a floor plan. So, here's an example of, understanding some extrinsics and properties of interior versus exterior of a window. The frame is something that it looks like it's a static size. It doesn't look like it can be changed in this particular family, but the width of the window can certainly be changed, and we want it to grow equally. So all of these are instructions that we have to give to the family, so we have to figure that out. So the way we pass instructions to our family a lot of times is through parameters. So that's where I started going with this, is kinds of parameters. So if I look at the kinds of parameters that are in my project or in this family right now, so here's my list, and we already saw some of these things. But if I was to add another one, I'm asked, not only whatever its name is, so example parameter, and the next is where the discipline is, who's going to be able to see it, so we have to think about who's going to see these parameters. The type of parameter is what we're going to use. So like I was describing, you can have lengths, or you can have text, or you can have integers, which are single numbers, or numbers, which are 1.56782, where integers would be 1, 2, 3, right? Or areas or volumes. All of these things are types of parameters, and the reason they're different, you may think, well, what's the difference between volume and area? Well, it's because, area is a square foot and volume is a cubic foot. So when you try to use these parameters in formulas, the units don't match up, you have to make sure that, you're working with the right kinds of units and stuff. And I talked about the URL, or we can set stuff to be a money. We can also use yes, no's, so on and off type conditions. So using that kind of parameter, we can turn visibility of things on and off. A lot of times you'll see this used for like the visibility of, say, a detail, kind of more detailed view will be turned off if the view setting is this, then turn this off. Or if a table gets so long, add a third leg to it. So that's somewhere where you could use a yes-no type parameter to control those kind of things. And there's one more down here that's kind of interesting, is the family type parameters. So not only can we make a family, a component family, we can also nest component families into other component families. So say you had a dining room table that you wanted to put chairs around. So you could build the table in one family and then nest in the chairs, and then that would make it possible, using a family type parameter, to swap out the chair depending on the dining room set. So the table's always the same, or when the table is round, it has certain kind of chairs, and when it's square looking, it has other kinds of chairs. So that's a way that you can do that kind of thing. So these nested relationships can be very complex. So using these different kinds of parameters are something that can add complexity to your model. So don't just think about them. We've, for the most part, used just length parameters, but there's certainly other things that you can use and hold all kinds of different information on your parameters. The kind of last piece, and we'll make a family in class and go through a lot of this stuff, but I just want to kind of lay the groundwork for it with this lecture. And so the last kind of thing is that when you're making families can be very tough to make, and when you're making all these relationships between things, you have to make sure that your parameters and everything's hooked up correctly. So a lot of times we do this we check for errors, and we do quality control by doing what's called flexing a family. So I'll do it here so you can see how it's done. So I have this 24 by 48 type, and I might change to a different type, and so all the parameters here have changed, and then I can apply and I can see it change and make sure that it's working. And then I might change to like a really big size and then hit apply and change. So we actually go through this kind of process when we make our family. We build up the geometry in such a way, and we build up these different constraints in such a way that we kind of do it one at a time and do this testing and flexing to look for errors the whole way through while we're building the family, because we don't want to build a complex network of things here and then only to find out we made a mistake very early in the process, and then everything doesn't work, and we have to spend a lot of time undoing that. So checking for errors, it makes the process of families take a lot longer to produce them, so it'll feel very tedious, but over time, catching the errors early is definitely something that you want to do and you want to check for. So, and then as part of the kind of, the last note here is, when we're making the family, we have to make sure that we don't create constraints that are going to compete with one another. So you can over constrain something so geometry can't get produced. So this flexing process is something that we can guard against creating an over constrained model. So I think that's a basic kind of introduction to the whole idea of creating new components or creating something that wasn't made before, building it in the family editor and then using it in your project. So the main key points here are that we're always going to have to make these things. When we decide to do it, we have to think about how it's going to get used, where it's going to get used, how variable we want it to be. And then once we decide what we're going to be making, we want to make sure we plan ahead of what we're going to make then go about making it. And as we make it, using the different kinds of parameters that we do and building our geometry, we want to do it slowly, one step at a time, checking for errors along the way. So we'll see you in class. We'll work on a family, and you'll see how it's done a little more practically. So we will see you next time. Thanks.